When an alert goes off in a complex system, you usually know that something is wrong. However, the moment you ask, why is this happening, things suddenly become unclear. We set out to answer that very why. Today, we'd like to introduce a new approach we've developed called structural temporal causality. Anyone who has worked with AI knows this moment. The system loudly signals that something is wrong, yet when you ask the most important question, so what's the actual cause, it stays completely silent. Our research started from that frustration, from that very question. Up until now, most anomaly detection methods have followed the same path, making models more and more complicated in the hope of solving the problem. The result? A black box. The more complex it became, the further we moved away from the root cause. So we chose a completely different path. Instead of hiding behind complexity, we set out to build a transparent box, something grounded in principles that lets us clearly see inside the system. Through our research, we realized something. This isn't about model complexity at all. We had misunderstood what an anomaly signal really is. We needed a paradigm shift, and here is the key insight we discovered. Anomaly signals appear in two distinct stages. The first stage is the collapse of time. Imagine a huge orchestra, and suddenly one performer starts to lose the rhythm. That's stage one. And what happens next? It immediately leads to stage two. Stage two is the collapse of relationships, where that single mistake ends up breaking the harmony of the entire orchestra. We redefine an anomaly signal as the combination of these two collapses. So how do we capture these two collapses? We do it through our approach, OracleAD. OracleAD works like a conductor with extremely sensitive hearing. It detects, with high precision, both the exact moment one performer falls out of rhythm and the moment that mistake breaks the overall harmony. Of course, a theory is only meaningful when results prove it. What you're seeing here is a performance comparison on an industry-grade dataset known for being extremely challenging. As you can see, OracleAD achieved an F1 score of 65.85. It's more than 18 points ahead of the second-best method. This isn't a small improvement, it's a decisive leap. This is what principle-based design delivers. And our work has been recognized not only in industry, but also on the most prestigious academic stage. Our paper was accepted at NeurIPS 2025, a conference acknowledged by AI researchers worldwide. This proves not just that the performance is strong, but that our approach is academically novel and meaningful. We're extremely proud of the outstanding performance and our NeurIPS acceptance, but honestly, that's only half the story. The true power, the real innovation of OracleAD lies not just in finding anomalies, but in diagnosing their root causes. While other systems simply flash a red warning light, OracleAD lays out a map showing the exact path to the underlying cause. As you can see here, it pinpoints which relationship among numerous variables is breaking that highlighted red link, and how that break is disrupting the entire system. There's no more guesswork. The cause is right in front of you. So what does this mean in real business environments? First, you can immediately identify the root cause of failures. Analyses that used to take days or hours now take just minutes. Second, you save enormous amounts of time and cost. And finally, and most importantly, you gain an AI system you can truly trust, one that not only predicts failures, but can actually be controlled. This sentence from our paper's conclusion captures everything we aim for. We didn't just build a high-performing model. We established a solid, transparent, principle-driven foundation on which all future research in this field can build. That's what we're most proud of. We've shown you the principles, proven them with results, and shared the future they lead to. Now it's your turn to experience this future of diagnostic AI for yourself. If you're curious about more details and a live demo, please reach out to us. We'll be waiting. Thank you.